So now it's time for our panel discussion. And you know already Andrew, but I have two gentlemen that you don't know yet. And they are experts in silicone, just like everyone else you have seen this morning. So now it's time for our panel discussion. And I have Alan Copini with me.
Maria.
Good morning.
Hi.
So you are engineer for custom parts.
Absolutely.
What is your specialty? What can you tell us about yourself?
Okay. I've been with the company for almost 13 years now. Previously working in manufacturing, and for the past 5 years in R&D, working on custom products. So anything which is not standard. So that's what we do.
And you're going to talk about that in a few minutes.
A bit more.
Thank you, Alan. Daniel Hauser. Hello. Good morning.
Good morning.
Hi, Daniel. You are our manager for sales development in Europe. So what can you tell us about yourself?
Yes. So I'm also almost 10 years with the company, responsible as a face to the customer in development projects and connecting the dots, I would call it. So we connect our customer, understand and translate the requirements to the huge competence and expert group within Trelleborg on the silicon side. And at the end, we are responsible for the final product.
Okay. Thank you, Daniel. Andrew, hello again.
Hello again.
From Webley. Now I'm very proud.
Correct.
Now I need to say it. So you're a technical manager.
I am.
And you are our materials specialist, more or less. What can you tell us about yourself?
I am the technical manager at Webley. I've been with that organisation for nearly 20 years. We became part of the Trelleborg group quite recently, actually. So a lot of this is new to me, but I'm enjoying meeting all of my colleagues, and very, very much involved with silicone in terms of the technical capabilities of the material, designing the material, formulating the material, and through to processing as well.
Perfect. And I'm going to start with you.
Okay.
So first question. So, Alan, and I think we've been talking about it throughout the morning, custom materials. What does this mean?
Yes. Well, I think to just jump back a little bit, I think the important thing to note here is that Trelleborg have literally decades of experience with materials. And that isn't just with elastomers, polymers, of course. That's with all other materials, whether they be used as a substrate, metals, fabrics. In conjunction with that, excellent knowledge, colleagues as such, and everyone else who's spoken today, innovation centres, research and development. So the overall ability to customise materials within Trelleborg is vast. So what is customisation of material? Well, I would say it's something that's quite difficult to achieve, something that's made tailor, something that's bespoke, something that's been designed specifically for the application in mind. And even, of course, our standard materials were once designed with an end goal in mind. And this is really where silicone has an advantage in terms of the way it can be customised for lots of different applications and lots of different industries. We spoke before about aerospace, medical, HVAC, conductive applications, food and beverage. I mean, silicone really is a very versatile material in terms of how it can be customised and tailored.
Thank you. And again, customization, bespoke materials, bespoke applications. Can you tell us about the customization of silicone rubber specifically?
Yes, of course, yes. So we spoke about liquid silicone rubber and high consistency silicone rubber. Both are designed for different things, but of course they both are silicone rubber. And so LSR is really a material that can be modified, that can be adapted, but Trelleborg has vast experience in terms of the processing of liquid silicone rubber, the grade selection, all of the ancillary automation and processing that goes with that material. And of course, Daniel will talk to you about that in some detail. The advantage of something like the high consistency silicone material in terms of customization is that we've got various derivatives of silicone to consider as well. We've got the phenol version of silicone, we've got the fluorinated version of silicone. On top of that, we've got the different catalyst options that you consider. Platinum, different types of peroxide, low temperature, high temperature. And then on that as well, we can further customize the material with specific additives, specific fillers that you can't easily do with liquid silicone rubber. And so the advantage of this material in terms of what we can do to it, what we can tailor it to is really quite remarkable. An example being with silicone, it inherently has a reasonable level of flame retardancy if that is what you need from your product. But what we can do with the high consistency silicone is we can add specific intumescent flame retardant fillers into that grade that further enhance the properties. Not only that, we can introduce things such as ash cohesion so that the product retains its shape if it was exposed to very, very high temperatures. So these sorts of things, the way in which we can customize the materials, are really key to Trelleborg's customers and how this material is really, really vital for them.
Thank you, Andrew.
Okay.
You were talking about high consistency
Silicone.
silicone.
Yes.
So now I'd like to focus a little bit on liquid silicone
Yes.
rubber, so LSR, and I'm looking at you, Daniel. So a question for you. So when we talk about this material, what are the USPs of the material, and what do you consider sweet spots in the market?
Yes, of course. So I think Caroline also mentioned quite a lot of USPs of the material. I want to focus on the special manufacturing properties. It means liquid silicone, we say it flows like water in the tool, in the mold. And this gives us the biggest freedom of design for our products, but also it's quite a challenge to find the right design. So this is where the knowledge or our experts really make a difference at the end. That means we can combine several products which are used in different products and markets. Already we combine them into one product. Less effort for assembly, less costs. A clever combination really leads to an innovative, long-term and sustainable solution. And not even combining only products or parts into one, we combine materials. And that means rubber to plastic or rubber to metal. And if we are confronted or we see an inquiry, we see an idea from a customer, we try to combine our knowledge and really find sweet spots to combine a plastic part with a silicone part. If you need accurate tolerances for a channel, for example, you would more do it in a thermoplastic part to have really the thermal stability for that instead of only doing silicone. So multi-component parts is a huge benefit, but you need to know how to design it. This is really the message. On the other hand, a sweet spot, I would say, especially Trelleborg has a lot of knowledge in the professional coffee machine area. So we like to design and realize products for that. And silicone is a perfect material for it. In case of compliance, as Caroline also mentioned, food and water compliance globally is quite easy to do for us. So the materials are ready for that. Healthcare medical, also compliance topic, and we are really experts in this field. And at the end, a very good example, which we are just working on, is really the PFAS topic. So also PFAS plays a big role in the industry currently, and we had several webinars on that. Our customers are driven by these regulations, and that means we want to also avoid PFAS material if possible, so from an engineering perspective. And we are currently changing or developing a new design. Instead of using a PFAS-affected membrane, we want to change it to a special micro valve, and it's really tiny. So that we have the same function, but with a totally different product. And this is used, or we also use it, make it in LSR with our design knowledge. And this is the point where I want to really hand over to Alan also, because product engineering, custom product engineering is making the difference here.
Yep. Before we go to Alan, I have one more question for you, Daniel. When we talk about partnerships, and that has been a topic this morning, so what would be a typical partnership situation or setup for a silicone project?
Yes, I think especially for silicones, but all over for all elastomers in our products is really important. If we're speaking about new developments, there need to be a commitment from both partners. So from us and also from our customer. And this is typically done by a joint development agreement or a development contract. This is really important. Then, as a next step, and also to stay a bit with that example of the PFAS membrane change, we invited the customer at the first meeting directly in our production site. Why? Because the customer, they are not experts in LSR molding. We know that LSR would work or can work as material, so we invited them to Stein & Rhein, sit together with all of the experts, custom product engineering, manufacturing, the customer, the designers of the product from customer side, and also us. And had a whole day workshop. First production tour, they understand our capabilities, and then we translate together these capabilities and the learnings. We give input from our end, and they show us the application with samples, with their products, with the CAD, and all together at one table. Later on, We are really digital and working in teams, but as a kickoff, it's necessary and it is really important. And at the end of the day, we had several possible designs in a design matrix, rated by all of the people involved, and then the way forward was quite clear. And we are making heavily progress on that, and it's really, it's a very fast way of working together.
And you're very close to the customers. You were talking about PFAS. So it's not only that we understand their application, but we also understand their pain points or their challenges, right? And we try to address them and to come to a solution as partners together.
Yeah, most important, yes.
Yes. Thank you, Daniel. So, Alan, a question for you. So you are the expert for custom parts. So when we talk about development, so we were talking about partnerships, but when we talk about the development process for a custom part or a custom product, what does it look like?
Sure. So the actual process itself is not different for LSR or for any other elastomer. So we always start just with any design process. We start with the application requirements. So we're looking at what the customer wants to seal, how much space we have for our seal, what are the operating conditions, so the temperatures, the pressures. If it's a dynamic application, we're looking at the speeds of the shafts, for example. All this information is absolutely necessary for us to come up with a good proposal. And that's why from early on, we always, if there's any missing information or if there's something not clear, we always reach out to the customer immediately. And we also look for specific requirements. So especially with, for example, with EVs now, with low friction requirements or assembly requirements. So it could be that the parts are going to be automatically assembled. So they have to be, for example, symmetric so that the automatic picking machine doesn't need to stay sorting it every time. Or we have to add poke-yoke features. These are all good to have at the first step of the project. And then once everything is clear for us, then we move on to the idea generation process. And now that depends on the complexity of the application. So if it's a simple application, then we could maybe do the idea generation process ourselves on our own. But if it gets more complex, like the case that Daniel mentioned, then we would involve a cross-functional team. So we could involve experts from materials, like Andrew, we could involve manufacturing from the start, especially if it's a completely new material, new process, then it's good to get the experts involved from the beginning. After that, we start our CAD work. It's 3D design, and then we do calculations, and it's your standard sealing calculations like squeeze and compression and stretch, and min and max conditions to make sure that, for example, when you have a seal in the max condition and the groove in the min condition, that there isn't too much fill in the groove and too much stress or extrusion. And we couple that with finite element simulation. So it's really a tight process. It's not just one design and one simulation. It's like an iterative process. So we come up with a couple of designs, we run simulations on them, and then we compare and say, for example, that design 1 is the better option, or design 2 is good, but design 1 performed better at high temperature, for example. Because in our simulations, we usually check for stresses. We make sure that the stresses are not too high, so that ensures that the seal will last a long time. And we make sure that, for example, when you heat it up to 120 degrees and apply 5 bar pressure, that the seal isn't behaving the way it shouldn't, so like extruding or something like that. And then once we're happy with the whole simulation, with the whole proposal, so it's not only one design, sometimes we come up with 2 or 3 proposals. Once we're happy with those, then we put everything into a presentation, and we share these directly with the customer. And hopefully the customer is happy with that, and we either go straight for prototyping after that, or else we need to go for another iteration of design process. So it's quite flexible. It's not always the same amount of time, but
yeah. And so it's very clear the expertise that we have in the room. So I'm very honored to be surrounded by experts. But Alan, what would you identify as very unique capabilities that we have?
I would say that the fact that we can offer such a customized product, it's not all sealing companies can do it. So we're offering something, I think, slightly different. And besides that, the fact that we have R&D centers located around the world, and we have one right here in Stuttgart, tied to our R&D site, it means that we can do product testing, so we can test our own designs, our own prototypes. We could benchmark them. We can do material testing. So we can create very accurate material models of our own materials. And that means that our simulations, our finite element simulations, and our molding simulations should be super accurate because they're actually using material data, which is of our own materials. And that's something quite unique. And the fact that they're here makes it easier because it means I can just get up from my desk and walk over and get the parts out of the testing and see what happened during testing. So that's a huge plus, I think. Another capability is that so the custom product engineering team is a small team, but we all have focus areas. So like my focus area is manufacturing and prototyping, but my colleagues are experts in hydrogen applications and finite element simulation. There's engineered polymers. And so whenever we're going through the development process, if there are questions, like if I'm designing something which is a rubber to plastic part, and on the plastic side, I'm not sure if this material is the right choice, then I would simply speak to my colleague who sits opposite me and ask him for his input, for example. So this is a huge, I think, for me at least, it's a huge plus. And well, Trelleborg has been in the sealing game for a long time now.
Over a century, yes.
Yeah, so there's a wide knowledge base that we can tap into. I mean, it helps us to find solutions quicker. Like, for example, for this application that Daniel was talking about, it came to us, but it wasn't a completely new design. So the application, so that's the design was already for another application for batteries in automotive vehicles, but it was made out of an EPDM material, and it was about 5 times larger. And when we saw this problem that the customer had, then we said maybe we could apply the same design or tweak that design for this application. So we ended up shrinking it. So it's like 2 millimeter or 3 millimeter in size. So it's much smaller, much tinier dimensions, and it's out of LSR because it's required for that application. So I think this is another benefit. And the final one, I think, is prototyping, but I don't want to go into too much detail because I think maybe Daniel will be talking about that soon.
Great. So Daniel, could you tell us about our capabilities in prototyping?
Yes, absolutely. It's also a personal interest of myself. So looking into different, really all kind of methods for rapid prototyping for elastomers or polymer products since many years now. Additive manufactured solutions like laser sintering and also all these kind of direct printing of seals are evaluated by Trelleborg. But the challenge is, and as I said, also for the design freedom overall, there are so many different methods and technologies to prototype parts. And the challenge for us is our customers expect that we find the best fit in a very short time, because prototyping, time to market, is key. Prototype need to be fast, otherwise it's not prototyping. And we think we can combine that. We have a huge knowledge on that. And for example, I can share with you, we can do, if it makes sense in the project, overnight doing a laser sintered plastic and then overmold it in a vacuum molding process. Then we have a first easy prototype. It is accurate, it can be really on tough tolerances, but it won't be in perfect serial materials. So it is a step before. But the next step would be rapid tooling. And we improved our capabilities over the last years enormously. So we are able to do a rapid tooling of a 2K part, a rubber to plastic part, with a thermoplastic mold and a rubber mold or a silicone mold within now 1, 2, maximum of 3 weeks. It depends on the need of the customer. Not everyone needs parts in 2 days, but I would say everyone needs them in 3 weeks if possible. So we really see this challenge and we want to be best of class here. And we are really on a high level. I'm always impressed what kind of products, also multi-component parts, which you later on in high serial production, you do that by real 2K processing or multi-component. That means molding everything in one tool in 2 stages, but you do it in overmolding as a prototype. This is the only way it makes sense to be fast and accurate on. And we have a functional prototype working in the application within, if needed, really 2 weeks. And this is impressive. It's in serial materials, in the right LSR, in the right rubber, and also in the thermoplast, for example, which we choose.
Right. Very impressive.
Yes.
But I will pick up on something that you said earlier. You were describing LSR. You said it flows like water.
Yep.
So now I'm looking at the materials experts in the room. So, and the way also that you were describing the materials, they sound like very noble. It's a very noble, flexible material.
Well, I think so, yes.
So what are the, so I'm right.
You are right.
It has very special and unique properties.
Absolutely, yeah. It's a wonderfully versatile material. And I think you've probably picked up on the enthusiasm amongst the teams here today talking about it. So, yeah, it's, I mean, coupled with the capabilities that Trelleborg have in terms of producing parts, incredibly intricate, detailed parts, multi-component, really complex designs, that coupled with this ability to tailor this wonderful material and do really interesting things to it. We can make it extremely electrically conductive. Conversely, it can be extremely electrically insulating, complete opposites. We can make it lightweight, we can make it ash cohesive, metal detectable, X-ray detectable. So having this ability to understand, tailor and develop the material in conjunction with processing it the way in which Daniel and Alan have described is yeah, it's fantastic, it really is.
They sound like superheroes. The materials. Yeah, well, you too as well. But the properties that you can give the material, depending on the application, it's like little superheroes.
Absolutely, yeah, it really is. It's really interesting.
Superpowers.
Yeah. Superpowers, yeah, I like that.
Great, thank you. Now I have some questions for you.
Okay.
These are questions from the audience. They are not my questions.
Okay.
So I'm just going to ask the question, and you can just pick it up and answer.
Okay.
Okay, good. So the first question, and I think this might be for you, Andrew, what is the chemical difference between a liquid silicone rubber and high consistency silicone rubber?
Okay, that's a good question. In the true sense, there isn't a lot of chemical difference. We're still talking about a chemical backbone which consists of silicon, which I spoke about, oxygen, and the various parts that come off that. The differences chemically are to do with the way in which it's polymerized. So LSR has shorter chain lengths, which results in a lower molecular weight, which basically gives rise to the flow properties that we spoke about before, and the fact that it flows like water. The way in which it's polymerized also gives rise to a unique way in which it has to be catalyzed. So it must be catalyzed with platinum, which is an addition cure technology. So that really differs to the high consistency grade, which chemically is the same, but because of its longer chain lengths and higher molecular weight, doesn't flow like water. It has more of a dough-like or plasticine-like consistency. But that enables us to do more to it in terms of adding fillers and so on and so forth. But chemically, that can also be cross-linked in multiple ways with either peroxides or platinums. So subtle differences at the polymerization stage give rise to these two materials and their different processing routes.
Okay. And we have a question on prototyping, which I think is a very interesting topic. So what is the advantage for customers to develop solutions directly with us instead of working with suppliers who would do the prototyping or prototyping suppliers?
I think I will go for it. This is a really interesting topic, and we are quite often confronted with that because there are suppliers in the market, especially in the additive manufacturing, focusing on elastic parts or elastomer parts. The difference and how we really make a difference is that we understand your requirements of our customers for the application, and it's not a cut-off. If they go with the prototype to another player in the market, they only request a make-to-print from them. They send a drawing or a CAD file, and they get the prototype in somehow a good shape, hopefully. But we can optimize it on sealing lips, on the quality which you really need to have on the sealing edge. Otherwise, the prototype is not functional.
Right.
So we optimize, and the last 10% which are needed is done by Trelleborg, because we understand the function at the end, and we can then translate all the knowledge and use it as experience from the prototyping to directly go to the serial. Often you face problems and you need to have an additional tool at your serial supplier then, and we know that because we are also doing quite a lot of projects where we are not the prototyping supplier, but we want to be, because we can add value and make it shorter, the time to market shorter, and also to lower the cost here. So this is a really important point. go with us. We are at the highest level of prototyping, and we have the capabilities and the knowledge to put everything together and be your partner from the beginning to the high serial production, or also to a mid-serial. It depends on complexity and everything.
And I think because we have the full picture, so we have been involved, hopefully, so we know the whole story around that particular part or application. And we have time for one last question, and this is about recycling. So how can we recycle biocomponent, so that means thermoplastic and LSR, at least how I read it, a biocomponent part?
Yes, that one's me.
Sounds like a
Nice,
material
yeah. There are a number of opportunities with silicone. So there are now grades of silicone which have been obtained through more environmentally friendly sources. It is a material which is available, as I mentioned before. It is abundant. And so there's a lot of things that can be done with silicone. We are able to recycle it and extract the silicone oil from it, which can then be used for other processes, other industries. It can also be ground down into a very fine powder. It doesn't technically remelt because it's a thermosetting material, so you can't process it in the same way that you often can with TPEs, TPUs, and plastics. So we're able to grind it down into a very fine powder. That powder can then be reused as a filler in other elastomers sometimes even in silicones, or that can then go on into other industries. I know there's a company recently that have been looking at using silicone powder in a very, very fine form to go into road surfaces and so on and so forth like that. So it's a really, really interesting topic of how the material can be recycled. And of course, Trelleborg, being the very, very environmentally and sustainable organisation that they are always looking to improve processes to reduce waste first and foremost, and then when there is waste, because inevitably there will be some through certain processes, that material is dealt with in a very sustainable manner and recycled wherever possible.
Yeah, that's what I was going to say. That Trelleborg, for us, for Trelleborg, sustainability is a big focus.
And rightly so.
And we're always trying to do better.
Yep.
Wherever we can.
Yes.
So I think this is a very clear and very interesting example.
Yeah,
Yes.
if I could.
Yes.
Also, sustainability comes in a lot in our design process. I forgot to mention this earlier. So it's one of our considerations, actually, is that when we have comparison of two designs, we try and go for the least amount of raw material. So we try and, if the groove dimensions are still open, we would suggest a smaller seal for that, for example. And we also target lower stresses, so that the lifetime of the seal is longer, so we ensure longevity of the seal. So that's how we try and give our part for a sustainable seal design.
Far more consideration going into ultimate life of these materials and products.
Yep. Wonderful. Thank you so much, gentlemen, for being with us and for your time and sharing your expertise with us.